Okay, I have a not right triangle here, and I can find the third side, but I don't use a squared plus b squared equals c squared. To find this side, which I am going to call c, I'm going to use a formula called the law of sines. Sine of big A over little a equals sine of big B over little b equals sine of big C over little c. You might be thinking, well, I see where C is in the drawing, but I don't see where this A and the B are. You get to actually pick. You know how there was pretty strict rules with a right triangle that C had to be the biggest side? In the law of sines, it doesn't matter which side is which. You could pick any letters. You could be using M, Q, and R. Doesn't matter. And the longest side definitely doesn't have to be called C. Now, I happen to choose that right away. I used C for that, but I didn't have to. Okay, so next, how do I actually solve this thing? Well, I got to first of all label this and give these some names. Across from little c is big C. The angles are big capital letters. Sometimes they use alpha, beta, and I think it's gamma. I don't know. They use three Greek letters sometimes, but usually we just use capitals. All right, then do you get that this could be A or it could be B? Remember how I said you get to pick? It doesn't matter. I'm going to call it A. If that's big A, though, then you have defined that the little a is over here, and it's 3. And then last but not least, the other corner, I'm going to call it B. Again, A and B could have been reversed. Big B is there, then little b must be here. Now, I can just plug stuff into my formula, and this is something that's going to always be true, is that sine of this angle, A, over little a, equals sine of the big B over little b, etc. Now, this is important that you get. I have 1, 2, 3, 4 pieces of information up there. Do you get that that's 6 places where I could put information? I can put 4 pieces out of 6 in there. That leaves 2 variables. If you happen to have it be like this, where I've got 2 variables left in here that I don't know, like let's say I don't know big A and I don't know big B, then I can't solve it. I have to have 3 out of the 4 pieces of info. Or if that didn't work, then I'd have to move over maybe these 2 guys over here, have 3 out of the 4 pieces of information. Or if that doesn't work, I have to get this and this to be equal to each other, and I'll have 3 out of 4 pieces of information. One of those is for sure going to work. All right, so next you got to figure out, what do you really want? Because a typical test question doesn't ask you to find every single thing. Okay, so let's make a goal. Do you want to find letter C, or do you want to find big angle A? Well, big angle A would be a little too easy, wouldn't it? Because doesn't it just add up to 180? Okay, so I'd say big angle A is a little easy. Let's go for finding side C. Well, that means for sure this is going to be one of the fractions that I use. But I got to be careful that I pick wisely on the other 2. I'm going to try to fill in 3 out of 4 pieces of this information, and then if it doesn't work, I'll adjust. I'm just trying to make the point, you don't always know which ones to fill in. You don't always just put in A and A, because maybe it's not going to work, because it's not going to give you 3 out of 4 pieces of info. All right, everybody put in big B, which is 45. Little b, which is 5. Big C, which is 100. And little c, which is little c. Sine of 45. Yes, you could do it exact, but today let's use calculators. Sine 45 0.707, which would be 0.71, over 5. Sine of 100 is 0.98 over c. When the variable's on the bottom, it's one of the few times where cross-multiplying is actually pretty smart. This time is that time. So I'm going to say 0.71c is equal to 0.98 times 5. I'm going to do that on the calculator. It's 4.9. Dividing both sides by 0.71. And I get I screwed up. I'm going to try it one more time. 4.9. I said 49. 4.9 divided by 0.71. There we go. 6.9. About 7. Raise your hand if you got the same thing as I did. Okay, awesome. Did anybody notice that I actually gave you more information than you even needed? See what I'm saying? You don't need much info on this, which is kind of cool because you noticed on those problems with the bearing question, you always were short on info. You didn't have quite enough. You didn't have enough angles. You didn't have enough sides. So the law of sines allows you to have very little info. Specifically, how much info do you need? 3 out of 4 pieces, right? As long as it's the right 3 out of 4. Let me show you what I mean. Let's say I had 3 out of 4 pieces of information, but it was like this. 40 degrees, 2, and 7. Do you get how I could not solve that one? Because I couldn't get any where I'd have 3 out of the 4 parts. I couldn't, like, look at these two. I don't have 3 out of 4 parts. I can't look at these two. I don't have 3 out of 4 parts. And I couldn't look at this equaling this because it doesn't have 3 out of the 4 parts. Do you get what I'm saying? So it all depends. If you get 3 out of the 4 parts, they have to be in the right places. Like, if I didn't know that C, but I did know this angle here was 60, then I could do it. It would work. Because I could solve right here and I'd find A. And then, do you get, once I know 2 of the angles, I immediately know the 3rd angle? All right. Okay. Then, can I solve it or not becomes the question. I'll warn you on some of the questions. The answer is you can't solve that one. There's no solution. So don't be freaked out if sometimes in today's homework, the answer is no solution. Can't do it because you didn't get enough info. All right. So here is a typical scenario where this works well. If you have an angle, let's say that looks like about 40 degrees to me, and you have the side across from it, let's say this side's going to be 5, then do you get that if you give me any other piece of information, I'll have enough info. I'll have 3 pieces of info if I give one more thing, and I've got an angle on the side across from it. What does that mean? In something like this, then, I'm going to have this and this, and if you give me one more piece of info somewhere else, it'll make one of those sets of 2 fractions where you got 3 out of 4 pieces of info. All right. I know some of you weren't following that. Here's the summarized Cliff Notes version of that. If you have an angle and the side across from it, the law of sines will work. If you don't, then sometimes it'll work and sometimes it won't. You want an angle and the side across from it. That's the ideal setup. And when I say sometimes you can make it work, it's like, what if you didn't know that angle, but you knew these 2 angles? You really do know the other angle? Okay, so you're really always going to want an angle and a side across from it, and you'll have enough to do law of sines. All right, so let's do a couple where we can actually see if you understood that well enough to get a nice clean blank page. You ready? Let's say it's 100 degrees. I've already banged on this drum enough. I think you know that I need side across from that. Let's say this is 12. Give me any other piece of information and we can solve for everything else. So somebody make up something. The only thing is, try to keep it in the scale of this drawing. Like if you say this is 112, then I got to redraw my picture because that wouldn't be right, right? I'll make a dice of destinies. Otherwise, I'll wait forever for somebody to volunteer. Row 4, last person. Give me a side. Give me an angle. Tell me something. Yes, it can. Then you should be able to figure out everything else. Now, one thing will be handy is if we all had the same letters and the same sides, so that when I say angle A, you would think the same thing as me. So let's call this A, let's call this B, and let's call this C. Solve for the other sides and angles. I'm going to pause. Food. Okay, so A squared plus B squared equals C squared would work in a right triangle, but I can't use that to find this third side. I can use A squared plus B squared minus 2AB cosine of C. Whew, that's a mouthful. That is the law of cosines. There, you've been introduced to the first 3 days of this chapter. If you could actually use that, you'd be done with day 2. So we're just for fun. I'm going to throw in the right numbers and solve for C. Did you get little c is the thing I don't know? Big C, I know, because these have to add up to 180. So 11 degrees? Thank you. And then I'm going to go A, little a, we just solved a second ago, it's right here. 11.39 squared plus B, little b is 12, minus 2 times A, well, I just said that one, 11.39 times B, which is 12, times cosine of C, well, there's C, which is 11, is equal to C squared. Do you get at the end? You're equaling C squared, therefore you have to take a square root to find out what C is. So all of that, you take that and you take the square root of it, and you'll have that third side. Is there an easier way? Absolutely there's an easier way on this problem. Just use the law of sines again. I know, what we just did was the law of cosines, but I'm saying we could find this by using the law of sines, and I'm aware of that. I'm just going to show you problems where you couldn't. Law of sines way of doing that is much simpler. So a theme I want you to get is law of sines is easier. I mean, look at that. There's 4 numbers, and you cross multiply and solve. It's easy. If you can use the law of cosines, use it. Law of cosines is there, but it's a pain in the butt, and you should only use it if you have to. Okay, so law of sines way is a lot easier. I would do sine of 11 over C is equal to sine of 100 over 12. Or I could have said sine of 69 over A, which we figured out was 11.39. But that's a lot easier than law of cosines way. So why is the law of cosines even there? Because what if you had this? What if I know all 3 sides? I don't know any of the angles. Do you think that would work with law of sines? No. Only 3 sides. I don't know anything in the angles. I'll never have 3 out of the 4 pieces that I need. So If I know the three sides are well, let's just do one we know, the 3, 4, 5 triangle. Then I can figure out all the sides. But wait, you say, that's a 90-degree angle. Yeah, this still works for right triangles. But it works for every kind of triangle. Give me any of the sides, any combination of 3 sides of a triangle, I can tell you all their angles by using the law of cosines. All right, I don't want to focus too much on the law of cosines because it's like advanced. We don't even need to know that yet. I'm just pre-introducing it because studies show that if you get a chance to see it early, you'll understand it better when we get there. Okay, so now you saw where the law of cosines could be used. Now let's look at your homework. We are so advanced. We're skipping over day 1 of this. We're going to get to day 2. So find the file that says day 2. I'm going to pause for a second. Okay, so here we are in the lesson called 11.1 day 2. And yes, we skipped over day 1. I know that feels weird, but we're on day 2. It's okay. We'll actually spend a little more time on this day in a moment. But for today, I just want you to try these 4 questions. 13, 14. You might think I'm going to say 15 and 16, but I'm not. You may skip 15, and we're going to do 16. By the way, when they use this weird Greek B, that's like a capital B. It's a beta. We're acting like it's a capital B. And so what's it across from? Little b. Okay? So when you see the letter alpha, that's like a capital A. Or the beta, that's like a capital B. All right. And again, you can check the keys on this stuff, so don't get all freaked out till you check into it. And it's as simple as you would think. Remember, one of those is not going to work.
14, is it?
We're doing 13 and 14. You're skipping 15. Oh, okay. Are you asking? I get what you're saying now, I think. You were asking if on number 14, if that's this capital C. Yes, it is. That's the Greek version of like a capital C. Okay, anyway, let's move on. I want you to do that problem because I want you to see that this is a lot like one of your problems you would have had on your test, except now you have a new tool, the law of sines. That'll make it easier. All right, that's all I have for the video for today.